Hi, my name is Jonathan, and welcome to Performing Day 2 Operations Part 2. So in this section, we're going to talk about Day 2 operations, such as more monitoring, logging, and using that REST API. So upon completion of this, you're going to be familiar with SD WAN logging, packet capture functionality, and the vManage REST API. So in summary, but basically to make this cut to the chase here, we're using syslog. Syslog is that traditional network monitoring tool that also fully supported on the SD WAN solution. You can configure a syslog server to which all the syslog messages should be sent, and use syslog locally on a system. The vShell, which is the Linux backend of the vEdge, so the vEdge is actually software running in a Linux environment. If you go log into the device and type vShell, you're actually moving yourself from the SD-WAN shell into the Linux shell. And it provides access to a multitude of log files, which can be accessed and viewed like on any other Unix system. Typical commands like grep, less, tail, sed, cut, and so on. You can cat files, etc. However, syslog is not strictly required for operation of the SD-WAN environment. Notifications are used automatically, and all important network events are going to be reported via those notifications to vManage, where they're going to be consolidated, and so we can have that single pane of glass. Therefore, syslog is only an additional optional networking tool. So, syslog also exists on the SD-WAN devices and works like traditional syslog on Cisco devices. If you do a show logging, just like on any Cisco router, you'll see the system log. Logging in remote syslog servers can be configured. So if you have an existing syslog infrastructure, each node can log to it. And local logging is enabled by default. Because there's an underlying Unix-based system, you can use standard Unix tools to look at those logs. A show logging command is as follows. Okay, we're logging to disk, and we're set to info and below, and this is where we're logging on the box. And our logging is set to 10 megs per file, and every 10 files we start overwriting them. So using that vShell command, so what we're going to do is we log into the vEdge, we go into type vShell, and then that moves us into a regular Unix shell. Right? And then cd into var log, just like any other Linux or Unix system, is where we can see our log files. And then there's our ls to list the contents. If you're not familiar with Linux, I would probably stay away from this. So we have a couple of log files here to take a look at. I'm just going to go over them really quick at a high level. The auth log, this guy right here, shows the login and log out, any super user events and authorization events. Let's see, let's move down to kernel messages. So kern log is all the kernel messages. Messages are the consolidated log files that contain all the syslog messages from all sources. vconfd, which is down there, it's all the configuration-related syslog messages. vdebug, it's all the debug messages for the modules whose debugging is turned on. So if you do a debug on the system, it actually sends it to this file. Okay. Basically, if any debug is set to above the priority value, that's where it will be put. It supports various levels of logging based on the module. Various modules implement the logging levels differently. For example, System Manager has 2 logging levels, on and off, while the Chassis Manager has 4 logging levels, off, low, normal, and high. You cannot send debug messages to a remote host. To enable debugging, use the debug operational command. So debug, and then ospf neighbor or whatever. And then go in here to look at the log. It does not log to the console. And then we have vsyslog, which is all the syslog messages from all Viptela processes, the daemons, above that configured priority value. The default priority value is informational. It's severity level 6. So therefore, by default, all notice, warning, error, critical, alert, and emergency syslog messages are going to be saved. So because we are a Linux environment, we do have the native TCP dump built into the system. All right? And that allows us to run a full packet capture. So basically, TC dump is that native Linux packet capture, which creates a PCAP file. Then we can export that off and then view it with Wireshark. We can use this to search for specific packet types and display for those packets anything from the flow information to a full hex dump. It's a very useful tool for proving the presence of certain packet types in the network, checking whether the DSCP bits were correctly set by the QoS configuration, and making sure the traffic was even hitting the Viptela in the first place. And here's an interface, just an example command. We're basically going to packet capture everything on gig 00. A major component of that SD-WAN architecture is its programmability. Software defined means that the entire network is programmable by an external controller. The interface between the SD-WAN network and this external controller is called an API, an application programming interface. The API for the Cisco SD-WAN solution is complete, which means everything can be done via API. Through that API, you can perform all operations that are available in the GUI. In fact, the GUI itself is using the API. So when you do something on vManage, you're actually running an API that generates config and sends it down. Well, it sends it to the vSmarts, and the vSmarts send it out. The API is therefore an extremely powerful way to program the SD-WAN network in a RESTful way. That's a representative state transfer if you're not familiar with it. Okay. Basically, we connect via HTTPS, and then we can use some get, put, post, and delete methods to actually send commands to the system. We also have all the API documentation is actually built into vManage. So if you go to the IP address of vManage/API docs right here, all right, you'll actually get this website, which will actually give you all the documentation for it. Remember, we're going to only be able to provide a brief overview of this functionality here. To actually see it, refer to this specific documentation. There's a long list of API categories which reflect all possible operations on vManage. Also, there's a Show Hide button here. If we click this Show Hide button, next to that API category enables you to show or hide all possible API calls in that category. This is a REST interface, which comes with some the following fundamental operations, such as get, post, put, and delete, as we talked about. And you can use the paths behind the operations in the API call. Okay? So these are actually the URLs for the actual API calls. Clicking a single API call retrieves the full documentation for the call, the complete syntax, and all possible return values. Click Try It Out at the bottom here, and to test that API on a running vManage. Oops. And then you'll end up getting the results. Basically, we're showing the request URL up here, right, which is the actual API call that we're using to get the response that we're seeing below. As a test, copy that request URL and paste it into a normal browser window. Then you can view the result in the browser, as shown in response body and response code. The response code here is a 200 OK, which means success, because it's a standard HTTP response code, which is of 200. So, in summary, basically, syslog it does exist on the SD-WAN device and works just like any other traditional syslog server. So if you have a centralized syslog environment, you can still send syslog messages to that environment. And we have full packet capture capability because we're running on a Linux system, so we have the full operational TCP dump. And with all of its command modifiers, you can specify what type of traffic you want to capture. And the REST API contains all those possible operations on the network. So we can actually use another external controller or program your own netconf and Yang systems to actually program the SD-WAN during possible outages to, let's say, move traffic to another circuit automatically. All right, that's the end of this section. Thank you for watching.